Well, joining us now is Edgar, who's a mining engineer with Rio Tinto, the managing partner for Resolution Copper in Superior, Arizona. And Ian is here at SME to talk about Resolution Copper, an update from 7,000 feet below the surface, and a technical talk later today. Ian, welcome to the show.
Thank you very much, Lee. It's a pleasure to be here this morning.
Okay. Well, it's an intriguing title, and I know there's a lot of news coming out of Resolution. So what's the key item that you're going to be talking about this afternoon?
Thanks, Lee. I'm going to talk about a couple of things. I'm going to provide a brief project update. We only have 15 minutes for the talk, so I'm just going to touch on a few key things. I'll provide a brief update on the permitting, on the land exchange, and of course the shaft sinking, which is the subject of the title there, 7,000 feet. And we're just completed that shaft, one of our great accomplishments. We're a little shy of 7,000 feet at 6,943, but that still makes it the deepest shaft in America.
In America or North America?
In America,
in America,
not North America. There are deeper shafts in Canada.
In Canada, okay. Well, the shaft is down there. What's the next step? You've completed that. Are you starting to move out, or are you going to be drilling another shaft?
That's a great question. So at this point in time, our next step is to construct a pumping station. The shaft is completed, and there is a quantity of water that is inflowing to that shaft. We're going to construct a pump station to protect that shaft.
Okay.
That'll take us through most of next year. And then the next shaft that we would construct after that would be the number 9 shaft, which is an existing shaft from the magma mine. Mm-hmm. It's down to just over 4,000 feet at this point in time, and we would deepen that shaft.
Okay. Will you have to enlarge it as well, or can you take the existing shaft and just continue down?
Yeah, so to date we've already rehabilitated that shaft down to below the 4,000 level, the old magma 4,000
right.
level. And to do that we removed all the steel. We'll maintain the same diameter. It's a 6.7 meter diameter shaft, and we'll deepen that to the same depth as number 10 shaft and connect the two shafts at depth.
Okay, now for those of our viewers who don't understand why you're doing this, what each shaft's going to do? What's the purpose of each of the two shafts?
Number 10 shaft is an exploration shaft, so that's one of the key things we're doing at this point in time is we're characterizing a number of things. We're collecting baseline data for the environmental permit, and we're collecting baseline engineering data. And number 10 shaft really ties into that baseline engineering data. So we've sunk down, we want to understand the rock mass response at depth, and that's what that shaft has given us a lot of information on. That's the purpose of number 10 shaft. Number 9 shaft then gives us that second means of egress. When we connect the two shafts together, we then have two ways into the mine and out of the mine, and that'll be the primary purpose of number 9 shaft. Then ultimately, once we get through the regulatory and legislative approvals, then those are the two shafts we would use to begin construction of the mine from.
Okay. Now, you mentioned a pumping station that's going to take most of 2015 to put in place. Why is it going to take so long for a pumping station? The depth, the temperature?
Yeah, so that pumping station, we anticipate completing probably in Q3 as opposed to end of the year, so sorry for the slight misleading. But the depth certainly makes things challenging. And initially when you break away from the shaft, there is a limit to how fast you can go. Everything you're bringing in is being slung down and taken back out. So construction is just relatively slow off a shaft station.
Okay. How much water do you expect to be coming in at that depth?
At this point into number 10 shaft, we're getting about 400 gallons a minute. We're getting around 200 gallons a minute into number 9. And then overall the mine is producing about 1,000 gallons a minute, which we treat and send down the Magma Arizona Railroad corridor down to the farmers.
Right, because early on you had already put a pipeline in place when you were dewatering the old magma operations, I understand, and sent all of that water down after treating to be used for irrigation.
Yeah, we still do that today. The mine produces a pretty steady 1,000 gallons a minute, which we treat, and then as you say, we send down, it gets blended with CAP water and used for irrigation out at the new magma irrigation district.
Okay, how hot is that water at the bottom?
So the water coming in right at the bottom is the same temperature as the rock, and it's coming in at about 180 Fahrenheit. And it cools off pretty quick. Okay. By the time we get it out to surface into the water treatment plant, it's down to about 130 at that point in time.
Okay, so not much hotter than the surrounding air in the summer up there.
That's right, yeah. It is hot enough to boil an egg, though, and the miners have tried that.
Okay. Well, that we'd like to see. Okay. So, in addition to the pump shaft, you mentioned you've got some regulatory and land issues you've got to get through. The U.S. House of Representatives just passed a bill that included the land exchange that you folks need to move this forward. Can you provide any more details or any insights on that land exchange and getting it through the U.S. Senate and in place?
Yeah, that's a great question, and we're pretty excited about that. I'm personally not particularly involved in the land exchange, so I don't know much more than is in the press, but it was great news last week. As you know, it cleared the House of Representatives. We're anticipating it'll be in the Senate today or sometime this week.
Oh.
And if the bill clears the Senate, then it'll be with the President. And he has, I believe, 15 days to sign the bill.
Okay.
And that's really exciting news. We've been working on that land exchange for over 10 years now. We made a couple of key changes, and I think those key changes are what enabled it to go on the bill, including the fact that NEPA would be conducted before we take title to that land.
That seems to be one of the key provisions. I don't want to put you on a spot because you say that's not your area you're focusing on, but do you have a sense of where the Senate stands on this? Does it seem realistic that the Senate, which is still Democrat controlled now, is going to pass this?
Yeah, so from those people that I've spoken to, they believe it'll pass.
Okay.
But as I say, it's not my area of expertise.
Right. Okay. Well, by the time this show airs, we will have seen if the Senate did act on it this week. So we'll have a better idea. So we may be adding a post note to this conversation by the time we air this program at the end of December.
Perhaps even by the end of today.
Maybe. Okay. That we'll keep an eye on. Okay. Well, is there anything else in your talk this afternoon that you think our viewers would be interested in hearing about?
I think one thing that's important to know is that we have filed a mine plan of operations. We completed that about a year ago. And although we hadn't received plan completeness from the Forest Service, we went ahead and made that public with their permission. So it's available on our website. We have a hard copy available in our Superior office. Mm-hmm. And we received a letter noting that the plan was complete from the Forest Service. So NEPA officially has begun on the project.
Oh, that's
significant. And I think that's really exciting. And of course, if you want to know some of the specifics of the project, they are available in that plan of operations, which is now over 2,000 pages long.
Wow. Well, big project, very complex project. Could I go back for a minute and help me understand, because I'm not an engineer. You get the two shafts down there and you connect them. Then how do you start your mining from there? What's this block caving technique is new for most of us, I think. How do you start with that tunnel connecting two shafts? Where do you go next?
Sure. Once we get down, there's quite a lot of infrastructure we need to construct in and around the shaft to enable mining to go forward. That includes refrigeration infrastructure, ventilation infrastructure, some areas where we can assemble mobile equipment. Once we have that infrastructure built, we're able to begin developing out towards the ore body. We then develop a series of tunnels that provide infrastructure so that ultimately we're constructing something like a rock factory. Caving operation is a high-speed, large-capacity underground mining method, and it takes a lot of infrastructure to do that. So we will drive tunnels to bring in cold air and to bring warm air back. We'll drive tunnels to bring ore back towards the crushing infrastructure so that we can crush that rock and bring it back to surface. There's quite a lot of infrastructure, and the construction times are long. From the point that we begin full-scale construction until we produce our initial copper, it's going to be something in the order of 7 to 8 years.
Wow. That's after the permits are issued. Everything's in
correct.
Place. Okay.
Yeah, and then there's a fairly substantial ramp-up period from that point on as well to be able to bring the mine up to full production.
Right. Okay. So all of that crushed rock is going to be going up one of those two shafts?
Yeah. So in the plan of operations, we have laid out the design. The mine is to the east of the existing number 9 shaft. Mm-hmm. The ore is brought up, but it doesn't actually come to surface. It gets taken by a conveyor tunnel below surface back to the existing West Plant site where the old magma mine concentrator used to be. The ore will be processed at that location. Then in the plan of operations, it describes a potential tailings facility to the west of Superior, about 6 miles west of Superior, 6 miles east of Queen Valley, somewhat equidistant between the two. The tailings would be stored there. The concentrate would then travel down the existing Magma Arizona Railroad corridor out towards New Magma. There would be some filter presses there to remove the water. The concentrate could then be loaded onto the Union Pacific main line that's in that vicinity. That corridor also enables us to bring back our water supply, which at this point we have banked approximately 50% of the project's water needs for the future. And that's banked through the Phoenix AMA through the existing Arizona Department of Water Resources administered water banking scheme. We also hope at some point to be able to secure rights to water directly from the CAP canal, the Colorado River water. and we have an application pending that is in for review now. And we've been recommended to receive a certain number of acre feet, a little over 2,000 acre feet a year of rights directly off the canal. So we hope that that comes to fruition.
Okay. A lot of long-term planning, putting all these pieces in place.
Absolutely, yeah. This is a significant project, and
Yes.
as you say, a big investment. We're at this point in time over $1 billion invested into the project, and a long way to go yet until we produce our first copper.
All right. Well, Ian, thank you so much for the update. This is exciting news, great progress, both on the land exchange, on getting the shaft down, and I think we're all excited to see your talk this afternoon and see the slides that go along with this. So thanks for joining us, and best of luck.
Thanks, Lee, and it'd be remiss for me not to mention that all of this is made possible by a fabulous resource. We have an amazing resource, 1.5 billion tons at 1.5% copper, and that presents a great opportunity for Arizona. You know, how we develop that, we hope to get input during the plan of operations from those that are interested in how that is done, and we really do support that feedback, and we're interested in it. And we hope that this great opportunity comes to be something great for Arizona.
Well, that's great, and we'll make sure we post the website on the program here so people can go and find out more details at your site.
Thank you, Lee.
All right, thanks for joining us.